Chapter 5, Developmental Influences on Child Health Promotion. This is an overview of all ages, and then we'll specifically go in and look at each age in later chapters. So, starting off with growth. Growth traditionally has been defined as physical maturation. A better definition, though, is to look at functional maturation. So not just how tall have you grown, but to include what the child is currently able to do. What's their function, their level of functioning. Okay, growth is defined as an increase in number and size of cells as they divide and synthesize and develop new proteins. It results in an increased size and weight of the whole child or of any of the parts, so any different organs in the child. Development, on the other hand, is gradual and it's an expansion. Children develop, they move from lower to more advanced stages of complexity, and development is physical, gaining skills. It's also emotional, cognitive. It covers all of those. It's an increased capacity through both growth, maturation, and learning new things and new skills. Now, percentiles, we tend to look at where children fall on a growth chart. We're looking at their percentile, which means if you take 100 kids the exact same age, where do they fall in that 100? Are they the 95th tallest, where only 5 are taller than them? Or are they the 5th tallest, so 95 are taller than them? That would be the 95th percentile if they're bigger than 94% of the kids, and the 5th percentile if they're in the just about the smallest. This is a poor picture of a growth chart. This one, just based on how that curve is, I think that's height. That's not the weight growth chart. Most of the time we're looking at weight or weight and height together. Okay, there's some principles that go with growth. Growth is a complex event. The endocrine system has to secrete hormones that tell the body to make changes. Genetic information is involved. The environment can affect it. The child has to have adequate nutrition to be able to build those new tissues, to be able to grow. So it's very complex. It's quantitative, which means it's measurable. That's your heights and your weights. It's also qualitative, which is increasing in abilities. Now, height and weight and change, it all varies. Kids are not the same. They'll grow at, one grows quickly and another grows slowly, and even for the same person. They'll grow real rapidly at certain points and then they slow down. There are some very specific ways that kids grow, though. Growth is continuous and it's orderly. It follows a process. And there's 3 principles to that. The first one is the cephalocaudal, which means they grow head to tail. And I think we'll look at that in a moment on the next slide. And then proximo-distal, so midline out to the periphery, out to their fingers and toes last. And differentiation from simple to complex. This is a picture that shows that cephalocaudal growth. So you can see the arrows, that's the direction the kid grows. They're growing, the head is the most mature when they're born, and then they're growing out in those directions. Their trunk grows first with these little tiny arms and legs, and then the arms and legs get bigger and more proportional. And you can see a baby when it's born, which is the top skull, their head is far more developed than their trunk or their extremities. their heads big compared to their bodies. And you can see that with the skulls. Now there are different periods of growth, and this all comes from the box 5-1. During infancy, kids grow very rapidly. That's the most rapid growth that they have. They slow down during preschool all the way up till puberty. They grow, but it's just at a slower rate. And then puberty, they have another rapid change. And here we get into those patterns of growth. They're sequential, which means they happen in a definite order. A child learns to sit up before they learn to walk. They learn to make vowel sounds before they learn to make words. There's also a developmental pace. So the order's predictable, but some stages happen very quickly and some go very slowly. And then there are sensitive periods. So there are certain periods that the growth and development is more important that it happen. And if it's interfered with in that stage due to illness or poor nutrition or some other factor, it's much more critical. And one example of that is the first trimester of pregnancy. That's when, certain exposures to the mom will cause all sorts of birth defects. This is also, I wonder if I have these tables labeled wrong, because this says 5.1. This is heights and weights, and there is always a question on an exam from this. This you are going to need to memorize. A child's weight, I have always used the rule of thumb that a baby should double its weight by 5 months and triple by a year. Your book says double the weight between 4 and 7 months. I'd be a little concerned if a 7-month-old was just now doubling their birth weight. But anyway, your book says 4 to 7 months, but they should triple their birth weight by a year. So a 7-pound baby should be 21 pounds at a year. During preschool and school age, they gain 2 to 3 kilos a year. During puberty, they gain a lot. They'll gain 7 to 30 kilos. Now, height, kids, you can estimate their adult height at 2 years of age by doubling it. So they're about half of their adult height when they're 2 years old. Between ages of 5 and 13, they should gain 2 to 3 inches a year. Then at puberty, they shoot up and they'll gain, depending on the child, anywhere between 4 and 12 inches during puberty. Skeletal growth and maturation. What happens is the bones ossify, so they collect calcium and harden, and then they're done growing. This begins first in the long portion of the long bones, and then it continues out to the ends. Again, it's that direction of growth. The diaphysis is the long portion, the epiphysis is the ends. Right before the end, you have the epiphyseal growth plate, and this is where growth continues for the longest. We can tell how close a child is to being fully mature based on that, the epiphyseal growth plates. And you can see on the baby's hand there, big gaps between the bones. They still have a lot of growing. And there's kind of a, just above the whitish edge is where the growth plate is. You can't really distinguish that on here, but you can see the difference between that and the adult hand. So what influences growth? Well, heredity. Tall parents have tall children and short parents have short children, and that's a big factor. Nutrition, however, is huge. You can have tall parents, but if a child doesn't get adequate nutrition, they'll never reach that potential for height that they had. Gender, boys are typically a little bigger, a little heavier, a little stronger. Disease, kids who have chronic diseases, they're spending all of their calories just surviving. They don't have calories for growing. And then environment, exposing children to certain hazards. Socioeconomic influences, children who don't get enough nutrition because of socioeconomics, or they may get enough food, but it's not nutritious food, so they're really not getting adequate nutrition. That will affect them. And season, climate, oxygen concentration. Do you live up in Denver or down at sea level? All those things will have at least a little bit of influence on growth. Going into systems here, the neurologic system, this is the one system that really develops prenatally. That's when the neurologic system is doing its most rapid growth. After birth, it's still increasing, but it's the length of the nerve cells are lengthening to go along with the growing child, and the numbers of connections between nerves. So instead of just this nerve connects to that one, now this nerve connects to that one, that one, that one, and that one. So the connections and the intricacy of the connections continues to mature, but the most rapid growth happened prenatally. Our lymphoid tissues, these would be your tonsils, your spleen. This is well developed at birth, and actually a child by the age of 6 has tonsils the size of an adult, or all the lymphoid tissues. You can imagine their throat is a whole lot smaller, but they have adult-sized tonsils. By the time they're 10 to 12 years old, they're twice the adult size, and then they start to shrink after that and get down to the adult size. I have a picture here showing the tonsils. These are actually infected. It shouldn't be red like that, and it shouldn't have the white patches, but you can see how large tonsils are compared to the child's throat. And the throat will get bigger and the tonsils will get smaller. So that's why they used to take everybody's tonsils out, because they really are huge on the